Welcome to today's class. Today's class, I'm going to explain you about benzene diazonium chloride, preparations and properties. Diazo group. What is a diazo group here? N2 group is called as the diazo group. N2 group is nothing but diazo group. So how you prepare this diazonium salts? Benzene diazonium chloride. So benzene diazotization reaction we do. Previously, I have explained you about the aniline chemical properties. Aniline on reaction with nitrous acid NaNO2 in presence of HCl. In presence of HCl, strong acid at low temperature, it forms diazonium chloride. This reaction is called as the diazotization reaction. This is called as the diazotization reaction. Sodium nitrite in presence of HCl, it forms NaCl and HNO2. It forms NaCl and HNO. So C6H5 and H2 aniline on reaction with HNO2 and HCl at 0 degree centigrade, it forms benzene diazonium chloride. C6H5 bond N plus double bond N NCl plus H2. Aniline on reaction with nitrous acid in presence of HCl at 0 degree centigrade, it forms benzene diazonium chloride. Now the preparation, as I've told you, benzene diazonium chloride, it can be prepared by reaction with aniline, NaNO2 in presence of HCl. It gives benzene diazonium chloride N double bond N with the phenyl group is the diazonium, benzene diazonium chloride with the liberation of NaCl and water. So what is benzene diazonium chloride? Benzene diazonium chloride is an organic compound with formula C6H5N2Cl. It is the salt of diazonium cation and chloride. It exists as a colorless solid that is soluble in polar solvents, including water. It is the parent membrane of the aryl diazonium compounds, which are widely used in the organic chemistry. And the solubility in water, it is very good. It is hygroscopic. The molar mass, it is about 150 to 150.57. And it has the hazards, it's unstable at temperature exceeding to 78 Kelvin. It is possibly an explosive. So this is the, and what is the importance? Why it is unstable? Because the diazonium salt is not isolated, it is water soluble compound, and at high temperature it can easily be soluble in water, which explains the unstable nature. So what is the importance? Coming to the importance, it is a colorless salt. So this diazonium chloride, it is a color imparting compound, organic compound. It is water. What is water soluble? The diazonium solvents, di refers to two, azo indicates nitrogen, and enium represents that cation or the diazonium salts. So diazonium salts are one of the most versatile combination of the organic and inorganic components. In general way, a representation of Rn2X. R is the organic group, generally an aryl group. X is an ion. So diazonium salts have chloride, bromide. So the name of the salts is based on the presence of the N2. So benzene diazonium chloride, we have seen, and now we'll see the preparation. Excess here. This is the importance of the benzene diazonium chloride. So benzene diazonium chloride compounds with salts are the group of the organic compounds which share the functional group. It has both the organic and inorganic moiety in its structure. And the excess of the acid in the diazotization reaction is necessary to maintain proper acidic medium for the reaction. It is a colorless solid. It has many uses in the organic chemistry. The benzene diazonium chloride, it exists as a colorless solid. There is no melting and boiling point values. Excess of acid in diazotization is necessary here. Why? Excess of acid is taken. So benzene diazonium chloride preparation, you have seen the formula C6H5N2Cl. Preparation is a diazotization reaction. Aniline aromatic amine on reaction with sodium nitrite in presence of HCl gives benzene diazonium chloride. So excess of acid is taken in diazotization reaction because it is necessary to maintain proper acidic medium for the reaction and to prevent combination of diazonium salt with undiazotized amine. So diazonium salts are prepared and used in aqueous solutions because in the solid state they explode. Properties are it is a colorless crystalline solid, it is soluble in water. It has a tendency to explode when it is dry. And benzene diazonium chloride at 0 to 5 degrees we prepare. Very low temperature with nitrous acid. If temperature if the temperature is increased, diazonium chloride decomposes to phenol. So the low temperature should be maintained. In the laboratory, if you will not see the nitrous acid in your chemical, so then how to prepare? Nitrous acid is prepared by mixing the sodium nitrite and cold dilute HCl. Sodium nitrite and cold dilute HCl. It leads to formation of HNO2. And on reaction of this HNO2 with NO will give you the benzene diazonium chloride. Benzene diazonium chloride is used as the raw material in the production of dyes. The use of this one is we categorize the reactions of benzene into two categories: reactions of substituting diazonium group by another group, or coupling reactions of diazonium ions. Benzene diazonium chloride is used as the raw material in the production of dyes. And reactions diazonium group, there are many groups. Benzene diazonium reactions of the benzene diazonium chloride. Chlorobenzene can be formed from benzene diazonium chloride when treated with the copper chloride. And bromobenzene is also formed from benzene diazonium chloride when treated with copper bromide. Benzene diazonium chloride is treated with copper bromide. Benzonitrile can be produced. These are the uses. Iodobenzene can also be prepared by reaction of benzene diazonium chloride with Ki. But you can prepare even the fluorobenzene by reaction of benzene diazonium chloride with fluoroboric acid. So there are many reactions. The benzene diazonium chloride, we can prepare fluoro, iodo, benzonitrile, bromobenzene, chlorobenzene. All this can be prepared using this. And for the dyes and in textile industries also, this diazonium chloride is very important. Diazo group is a color imparting group. Now let us see the stability. Coming to the stability, it is relatively most stable than the alkyl diazonium chloride salt. The arene diazonium chloride ion is resonance stabilized. It is resonance stabilized as it is indicated by the following resonance structures. See, the stability can be explained based on the resonance structures. You can see benzene, diazonium chloride, benzene diazonium chloride, resonating structures of the benzene diazonium chloride, where the pi electrons are shifting to the above nitrogen atom, and simultaneously to fulfill this valency, one more pi bond is electrons are shifting to another nitrogen. So you get the plus charge, and here you get the minus charge. And similarly, one more pi bond is shifting, electrons are shifting towards the positive charge. The positive charge is shifting from ortho position to the para position. And again, the positive charge is acquired at the para position. And now, the pi electrons are still shifting towards the positive charge backwardly. Again, the positive charge shifts from para position to the ortho position. Finally, you're getting one more structure here. Again, this structure, the pi electrons are shifting towards the ring. Okay, and the n minus electrons are shifting towards the double bond. So somehow you're getting the 3 resonance structures. 4 resonance structures are obtained. By this, we can explain the stability of the arene diazonium salts. It is relatively more stable than alkyl diazonium salts. The arene diazonium ion is resonance stabilized as it is indicated by the following resonating structures. Coming to the chemical reactions, benzene diazonium chloride on reaction with copper ion in presence of phosphoric acid and water, hypophosphorus acid, a benzene is formed, nitrogen is liberated out, nitrogen gas, phosphoric acid and HCl is formed. And similarly, this benzene diazonium chloride on reaction with ethanol, it forms benzene, liberating nitrogen gas and HCl, and formaldehyde is formed. Now, the benzene diazonium chloride on reaction with copper bromide in presence of HBr, and bromobenzene is formed with the liberation of the nitrogen. And still there are some more reactions. Benzene diazonium chloride on reaction with copper chloride HCl, chlorobenzene is formed and nitrogen is liberated. This is Sandmeyer reaction. Benzene diazonium chloride on reaction with copper in presence of HCl, it forms chlorobenzene with liberation of the nitrogen and copper chloride. Gattermann's reaction. This is called as the Gattermann's reaction. Now, benzene diazonium chloride on reaction with copper in presence of HBr, it produces bromobenzene with nitrogen liberation and copper bromide formation. Benzene diazonium chloride on reaction with KCN and copper cyanide, it gives benzonitride with liberation of the nitrogen. Benzene diazonium chloride on reaction with Ki, it gives iodobenzene, N2, and KCl is formed. Iodobenzene with liberation of nitrogen gas and KCl. Benzene diazonium chloride on reaction with fluoroboric acid, here benzene N2BF4 is formed, Barth-Siemens reaction, fluorobenzene is formed. Again, benzene diazonium chloride on reaction with water in presence of sulfuric acid, phenol is formed with liberation of the nitrogen and HCl. Next, Benzene diazonium chloride in presence of phenol at pH 9 to 10 core. Para-hydroxyazobenzene is formed, a orange dye, N double bond N. Para-hydroxyazobenzene is formed. Next, this benzene diazonium chloride on reaction with aniline at pH 9 to 10 cold, para-aminoazobenzene, the yellow dye is formed. Amino group is there here, yellow color. If OH group is there, orange color. So para-hydroxyazobenzene and para-aminoazobenzene. So on reaction with phenol, hydroxy groups is getting substituted. And on reaction with aniline, the amine group is getting substituted. Both of them in the cold and alkaline pH conditions it is taking place. Now let us see the next reaction, that is alkyl cyanides. Alkyl cyanides, these compounds have the formula RCN or carbon triple bond N. These are also derivatives of the amines. According to nomenclature, IUPAC nomenclature, cyanides are named as alkyl nitrides. Butane nitride, cyanobutane. Butene nitride, benzene nitride. This is butane nitride or cyanobutane, common. This is benzene nitride or cyanobenzene. We'll see preparations of these amines. From alkyl halides, Rx on reaction with KCN at 100 degrees centigrade, RCN major RNC is formed. And from acid amides, RCONH2 on reaction with P2O5 on heating and dehydrating, RCN is formed. Now coming to the physical properties, these are the neutral compounds with pleasant odor. It is similar to the bitter almonds. These are soluble in water as well as in the organic solvents. These are the poisonous but less than hydrogen cyanide. So cyanides are the neutral compounds with pleasant odor similar to that of bitter almonds. These are soluble in water as well as in the organic solvents. These are poisonous but less than HCl. Next, coming to the chemical properties. Hydrolysis reaction. RCN on hydrolysis gives amide. And this amide on hydrolysis gives acids with the liberation of ammonia. The next reaction is reduction. RCN on reduction in presence of sodium and ethanol, it gives RCH2NH2. RCN and 4H, lithium aluminum hydride, RCH2NH2 is formed. Amines are formed. Cyanides on hydrolysis, amide is formed, and further hydrolysis, acids are formed. A very best example always, once if you want to increase any carbon, we have to react with cyanide, then hydrolyze. You get the acid. Cyanides always on hydrolysis give amide and acids. Partial hydrolysis, amide, and complete hydrolysis, acids. Reduction. Alkyl cyanide on reduction, it gives amines. Again, cyanides on powerful reduction, the same amines are formed. This is Mendius reduction. Cyanides on reduction in presence of tin chloride and HCl, imine hydrochloride is formed, which on hydrolysis gives aldehyde and NH4Cl. RCHO is formed and ammonium chloride is liberated. Now reaction with the Grignard reagent. Alkyl cyanides on reaction with the Grignard reagent are MgX. Ether is formed. Ether, see, R, C, double bond R, N, MgX. On hydrolysis, it gives ketone. So reaction of cyanide with Grignard reagent and then hydrolysis, we get a ketone. We get a ketone. Now alkyl isocyanate we'll see. Cyanide is Cn, isocyanate is Nc. CH3Nc is methyl isonitrite. Phenyl isonitrite, benzo isonitrite. We'll see the preparations. From alkyl halides, this Rx, on reaction with AgCl, ethanol and heating, we get RNC. We get RNC, major product, and RCN is also product form, but it's a minor one. Carbonyl carbide amine reaction. A very best reaction for the amines which I've told you, detection of the primary amines. R and H2 on reaction with CHCl3, on reaction with CHCl3 chloroform and 3 moles of alcoholic KOH. On heating, we get RNC plus 3 KCl is formed and water is also formed. From N-alkyl formamide, RNH, C double bond O, H. In presence of phosphorus chloride, in presence of pyridine, RNC is formed, isocyanate is formed. Now coming to the physical properties, these are colorless, unpleasant smelling liquids. These are soluble. These isocyanates are colorless, unpleasant smelling liquids. These are soluble in organic solvents but insoluble in water. Okay. So these are the preparations of the isocyanates. One is from alkyl halide, the other one is carbylamine, and from N-alkyl formamide. So N-alkyl formamide on reaction with phosphorus chloride and pyridine, you get isocyanide. The physical properties also I've told you, unpleasant smelling liquids. These are soluble in organic solvents and soluble in water. Coming to the chemical properties, hydrolysis of isocyanates give reaction with water is hydrolysis. It gives RNH2 and HCOOH. HCOOH is formed. And reduction process, isocyanates on reduction, it gives, that reduction takes place in presence of nickel, platinum, or palladium, or sodium ethanol. The secondary amine is formed. Here it gets reduced, the pi bond is broken, hydrogens are getting added on the both places, and thereby secondary amine is formed. And next, addition reactions. Due to presence of unshared pair of electrons on carbon atom, alkyl isocyanates give addition reaction. Due to presence of unshared pair of electrons on carbon atoms, alkyl isocyanates give addition reactions. RNC plus sulfur gives rise to RNCS. RNC plus HGO, alkyl isocyanide, on reaction with the sulfur, it gives alkyl isocyanide and sulfur addition product. Direct addition of the element takes place. RNCS. Similarly, RNCHGO, it gives RNCO, cyanate. RNC on reaction with mercuric oxide, it gives RNCO and mercury. RNC on reaction with ozone, O3, cyanate is formed. RNCO, cyanate is formed. And isomerization reaction, let's see. At 250 degrees, it isomerizes to form nitrile. Here, RNC, on heating it forms RNC, isomerization. NC turned to CN. Now, nitro compounds. We'll see the nitro compounds, the preparation and the properties. Nitro compounds are obtained by replacing one hydrogen of the hydrocarbon by NO2 group. These are named according to IUPAC system as nitroalkane. Methods of preparation from alkyl halides. RX on reaction with AgNO3 gives RNO2 and AgX. Nitrating mixture is nitric acid and sulfuric acid, concentrated HNO3 and concentrated H2SO4. So benzene on reaction with the nitrating mixture will give nitrobenzene. So we are able to prepare aliphatic nitro compounds and aromatic nitro compounds. Alkyl halide on reaction with silver nitrate gives RNO2 and AgX. Silver nitrate. And similar aliphatic and aromatic nitro compounds are prepared. Physical properties. These are the colorless, pleasant smelling liquids. Their boiling points are much higher than isomeric alkyl nitrites. These are less soluble in water but readily soluble in organic solvents. Now, chemical properties we'll see. Reduction generally takes place with SnHCl or catalytic hydrogenation, or nitroalkanes are reduced to amines. So reduction can be done with tin chloride or palladium, platinum, or nickel in presence of hydrogen, catalytic hydrogenation. They are getting reduced to amines. We'll see the reaction. RNO2 on reduction with tin chloride, primary amine is formed with liberation of water. If neutral reducing agent like zinc dust, ammonium chloride is used, hydroxylamine is obtained as major product. RNO2 and 4H in presence of zinc ammonium chloride, RNHOH is formed, N-alkyl hydroxylamine is formed. In presence of ammonium sulfide and sodium sulfide, selective reduction also takes place. So nitro compounds on treating with the zinc dust and ammonium chloride, hydroxylamine is formed as the major product. In presence of ammonium sulfide or sodium sulfide, selective reduction takes place. Here, meta-dinitrobenzene on reaction with yellow ammonium sulfide. Here, one of the NO2 group is reduced to NH2. This is xenin reduction with liberation of ammonia, water. Now, benzene, how it reacts in different medias, we'll see. Nitrobenzene gives different products with different reagents in different mediums. Nitrobenzene in acid medium gives, if the reagent is tin chloride, it gives aniline. Nitrobenzene in the neutral medium, the reagent is zinc ammonium chloride, N-phenyl hydroxylamine is formed. In the alkaline medium, you can take all these reagents, zinc, sodium hydroxide, ethanol, zinc sodium hydroxide with ethanol, sodium arsenate with sodium hydroxide. So you get azoxybenzene or azobenzene or hydroxybenzene depending on the reagent that you take. And metallic hydride, nitropenzene on reaction with the metallic hydride, that is lithium aluminum hydride, aniline is formed. Electrolytic reduction, if you do, dilute H2SO4, para-amino phenol is formed. So this is the different mediums and different products formed by nitrobenzene. So what is the action of nitrous acid? A very important reaction. Primary nitroalkane gives nitric acid with red color on reaction with sodium hydroxide, or CH2NH2 on reaction with HNO2 gives nitric acid, which on reaction with sodium hydroxide, red color product is formed. Now, secondary nitroalkanes give pseudonitrols with HNO2. Two R groups are there, it is secondary nitro group. See, for NO2 attached alpha carbon, two R groups are attached, so it is secondary nitroalkane. It gives pseudonitrile with HNO2. Pseudonitrile is formed. One is NO group and the other one is NO2. It is pseudonitrile, which on reaction with sodium hydroxide, a blue color product is formed. Now, the next reaction is a very, very important reaction, Neff carbonyl synthesis, Neff reaction. Nitroalkanes, Neff reaction synthesis, sodium or the potassium salt of primary or secondary nitroalkanes gives carbonyl compounds on acidification with 50% sulfuric acid at room temperature. This is called Neff carbonyl reaction. A nitro compound on reaction with sodium hydroxide and 50% sulfuric acid gives aldehyde. This is Neff reaction. Now, electrophilic substitutions, nitration, what happens? Nitrobenzene gives metadinitrobenzene. NO2 group is the deactivating group, metadirecting group, and strongly deactivates. Nitro group it deactivates, so ortho product is not formed. Para ortho product will not be formed. Unless you protect this oxygen, the ortho para cannot be formed. So that this deactivating group directs nitro group to meta position. So electrophilic substitution takes place at the meta position, metadinitrobenzene is formed. Now, nucleophilic substitutions. NO2 group activates the ring towards the nucleophilic substitutions. This NO2 group, on reaction with base, slowly, thereon fast, it forms metanitrophenol or orthonitrophenol or orthonitrophenol is formed. And metanitrobenzene, if you take potassium ferricyanide in presence of sodium hydroxide, we get one, see here, one position you're having OH, and the second position and sixth position you're having nitro groups. So 2,6 dinitrophenol is formed. Similarly, even at the meta position, it is getting, see, even at the para position, you are getting. So this one, it is, yeah, one position, this one, 2 and 4. 2,4 dinitrophenol can be formed. The next one, para-bromonitrobenzene, on reaction with KCN and ethanol, we get meta-cyanobromobenzene is formed. So these are the reactions of the nitro compounds. So today's class, what I've discussed is all these reactions. Just by seeing the PPTs, you can understand. But still, you need some of the explanation, the compound names. So I've explained you. So today's class, what I've dealt is benzene diazonium chloride, preparation, properties, stability, resonance, chemical properties, and cyanides preparations, properties, isocyanides preparation and properties, nitro compounds preparations and properties are discussed in this class. I hope everybody have understood today's class. It is slow, but this is the way a reaction should be explained. So I hope you have understood today's class. Thank you for listening to my class.